Okay, AddMaths2008 Question 12. It's a linear programming question. You've got lots of details given on the question paper, and in part 1 we have to show that the worker hour constraint reduces to what's given on the page. X is the number of tables, Y is the number of chairs. I would write that down in case you get confused as you go through. You can see what's happening. Well, the worker constraint, we do know each table requires 12 worker hours, so every X takes 12 worker hours. Similarly, for every chair takes 6 worker hours. So that is the total of worker hours we've got. And we know there are 24 workers working for 40 hours. So we've got 24 lots of 40 is the number of hours. So the number of hours needed has to be less than or equal to the number of hours available. If you work out 24 times by 40, you get 960. And what you can do now is divide each of these through by 6 to get 2x plus y is less than or equal to 160. And that is the first constraint you need in part 1 of this question. Okay, for part 2 we've got to find 2 other constraints. First of all, we've got to find a constraint to do with the cost. If we look at the information we're given, we are told that each table, which is an X, costs £30, and each chair, which is a Y, costs £10. So that's how much the costs are. And we do know that we have available to us a maximum of £1,800. So we have that for our cost constraint. What we can do here is divide everything through by 10, so we can get 3x plus 1y is less than or equal to 180. The other constraint we've got to find here is a constraint on the numbers of tables and chairs. It tells us we need to make at least 3 times as many chairs as tables. So the chairs number must be at least 3 times the tables number, which gives you y is greater than or equal to 3x. Part 3 is about producing the graph. I've labelled the 3 constraints we've got at the moment, constraints 1, 2 and 3. And for each one we need to work out how we can draw it on the graph. The first one, 2x plus y, I'll put an equal sign in there for the moment just to get the line as 160. If you cover the x's up so there are no x's, y is 160. If you cover the y's up, so y is equal to 0, 2x is 160, so that means x must be 80. So for that one, we know that that line will go through 160 on the y-axis and 80 on the x-axis, and will look like that. For the second constraint was 3x plus y, 180. If you cover the x's up so there are no x's, we get y is 180. If you cover the y's up so y is 0, we get 3x is 180, so x is 60. So on that one we'll have 180 on the y-axis, we'll have 60 on the x-axis, and we'll have that line. Constraint number 3, if you think of the line y equals 3x, that will go through the origin. It's a straight line, and that will go through, for example, the point 1, 3. And if we know we're dealing with an x of 60, so for example when x is 60, that will go through 180. If you look at the 3 sketches to put those all together for a minute, we've got x number going out to 80, and we have y numbers going up to 180. So when we come to do our drawing in a minute neatly, we need a scale that encompasses those 2 extremes. So on the x-axis we need 80 marked, and we need 60 marked. On the y-axis we need 180 marked, we need 160 marked. So constraint 1 was 160 to 80. Constraint 2 was 180 joined up to 60. And the third one went through the point 60, 180. So we're going to get another line going up there like that. Now that's not drawn accurately, but I would always actually do that sketch before I went and did it neatly. Constraint 1 and 2 were both less than constraints, so I do not want to the right of either of them. And I know y has to be greater than 3x, so y has to be above this line, so I don't want above that line. My feasible region is going to be that triangle there. If you draw it accurately, I'm just going to look at the one that's on the mark scheme at the moment. That is the graph that you should get. And that's on the mark scheme, and that file is also available on the KLP. For part 4 of the question, we've got to come up with the objective function. We know the profit for each table, and the tables where X is £20. So for every one of those, there's £20 profit. And for every chair, we're told that there's £5 profit. So that is the profit that we make. So we'll call that P, and that's the objective function. So that's the answer to part 4. Part 5, okay, I'm going back to the mark scheme answer a minute for the graph. Here we go. And on part 5, what we need to do is to draw on the objective function. The objective function, which was this, we need to let that equal any number we like. What do 20 and 5 go into? They go into 100. So first of all, if you start with this, because all we're after is the gradient, if we started with that, again this number is just any number you want. If these two go into it, that's great. Because if I draw that, if x is nothing, y will be 20. And if y is nothing, x will be 5. So I now actually need to put that line on my finished graph. So I had 0 to 20, which is here, and I had 5 0, which is here. And if you do that carefully, get that gradient, I want where that line slides out and leaves the feasible region as its last point. And if you do it accurately, you'll find it is here at the point 390. So that tells you you will get the best answer you can when x is equal to 30 and y is equal to 90. And it's asking you for the number of tables and chairs, so we'll actually write down at the end of the question, linking back not just x and y's but to the actual things it's talking about. You want 30 tables and you want 90 chairs. And that is the final answer for that question.